Hello everyone, we are solving the IIT JAM Geology paper of 2024, and here in this question we have the plate tectonic setting of Benioff-Vodati zone is which one? Four options are given, we have to choose the correct option. Now the Benioff-Vodati zone, also known as the Vodati-Benioff zone, is a zone of seismic activity which is inclined beneath and parallel to the overriding plate in a convergent plate boundary. And over here, what happens? One tectonic plate is being subducted beneath the other. Okay. So over here, the correct answer would be subduction zone, which we have in option B. Now, option A, C, and D. Why aren't they coming under the correct option? That is what we are going to discuss right now. Starting with option A, which says continental rift. Let's zoom in a bit. Continental rift. Now, continental rift refers to a place where a continent is being pulled apart, okay, leading to the formation of a rift valley. And Benioff-Vodati zones are not associated with continental rifts. Coming to option C, that is a passive margin. Passive margin refers to the transition between the oceanic and continental lithosphere that is not an active plate boundary. Now, Benioff-Vodati zones are associated with active plate boundaries. Okay, so hence this is also not correct. D. Mid-oceanic ridge. Mid-oceanic ridge is a divergent boundary where tectonic plates are moving apart, leading to the formation of new oceanic crust. Now, Benioff-Vodati zones are associated with convergent boundaries where the plates are moving towards each other and one is being subducted beneath the other. Okay, it's like that. One is being subducted beneath the other. So hence our answer is subduction zone. Alright, let's move over to the next question. It says neutron-rich unstable nuclides undergo which of the following? Our answer would be beta minus negatron decay. Okay, and let's talk about the neutron-rich unstable nuclides over here as mentioned in the question. Now, neutron-rich unstable nuclides, they have an excess of neutrons compared to protons, and this makes them unstable because the strong nuclear force which holds the nucleus together favors a more balanced ratio of protons and neutrons. Coming to our correct answer, let's discuss about this. Now, beta minus, that is negatron decay, it's a process where a neutron in the nucleus decays into a proton. Okay, and an electron, that is beta minus particle, and an anti-neutrino, that and an anti-neutrino. This process, it increases the number of protons and it decreases the number of neutrons over here, moving the nuclide closer to the valley of stability. Okay. Coming to B positive, a positron, beta positron decay. Now, beta positron decay is obviously the opposite process that is going to happen over here, where a proton decays into a neutron. Now, a positron beta plus or beta positron particle and a neutrino, this process is less likely for neutron-rich nuclides because it would further increase the neutron to proton imbalance. Next, we have the alpha decay. Now, alpha decay, it involves the emission of an alpha particle, two protons and two neutrons from the nucleus, and this process decreases both the number of protons and the neutrons, making it less favorable for the neutron-rich nuclides. Okay. Next is electron capture. Electron capture occurs when an inner shell electron is captured by the nucleus, combining with a proton to form a neutron and releasing a neutrino. Okay. Now, this process also increases the number of protons and decreases the number of neutrons, making it a viable decay mode for neutron-rich nuclides. So over here, we are going with beta negatron decay, and this is the most likely decay mode for neutron-rich unstable nuclides because it directly addresses the neutron excess and moves the nuclide towards a more stable configuration. Okay. Next, let's move over to the next question. Next question is, which one of the following textures is found in alkali olivine basalt? Over here we have rapakivi, graphic, blastoporphyritic, and intergranular. Okay, let's examine each of these options which we are provided with. Rapakivi. Now, rapakivi texture is a type of perthitic texture. Okay, perthitic texture. Perthitic texture, which is found in some granite rocks characterized by large orthoclase feldspar crystals surrounded by finer grained matrix. And this texture is not typically associated with basaltic rocks like alkali olivine basalt. Okay. Next is graphic. Graphic texture is a type of intergrowth texture where two minerals, often quartz and feldspar, they grow together with no space between them, and this texture is more commonly found in granitic rocks rather than basaltic rocks. Okay. Next is blastoporphyritic. Blastoporphyritic texture is characterized by large phenocrysts, means individual crystals. Phenocrysts means individual crystals in a finer grained matrix, and this texture is often found in porphyritic rocks where there is a significant difference in the crystal size between the ground mass and the phenocrysts. Now, while alkali olivine basalt may contain the phenocrysts, it typically doesn't exhibit a blastoporphyritic texture. Okay. Next we have is intergranular. Now, intergranular texture, it refers to a texture where the minerals within the rocks are not touching each other. Okay, and there are spaces or interstices. The spaces in between them are called the interstices between them. Okay, and this texture is commonly found in basaltic rocks like alkali olivine basalt, where minerals such as olivine, pyroxene, and plagioclase, they form the distinct crystals with space between them. Now, the most suitable texture for alkali olivine basalt is intergranular. Okay, so we are going with intergranular. Now, alkali olivine basalt is a type of basaltic rock which is characterized by the presence of olivine phenocrysts, and it's a fine-grained matrix of other minerals such as pyroxene and plagioclase. And the intergranular texture, it refers to the presence of distinct mineral grains like crystals with spaces between them, which is a common feature of the basaltic rocks. Hence, we are going with intergranular. Let's move over to the next question. The mineral assemblage found in a granulite facies basalt is which one? It's a combination of which one? First, let us talk about granulite facies over here, which is of important discussion over here. Facies in metamorphic rocks, it refers to the specific mineral assemblage that develops under certain pressure and temperature conditions. Coming to granulite facies, Now, these facies, they represent high temperatures and moderate to high pressures. Okay, typically exceeding 700 degrees centigrade and 4 kbar. Okay, next is metabasalt. Metabasalt is a basalt rock that has undergone metamorphism, transforming its original minerals into new ones under the influence of heat and pressure. Okay. So now we are going to talk about these options which we have over here. First we have the glaucophane plus lawsonite and chlorite. Now this assemblage is a characteristic of the blue schist facies, which occurs at high pressures and lower temperatures compared to the granulite facies. Okay, so this one done. Next is orthopyroxene, garnet, plagioclase, clinopyroxene and quartz. This assemblage is a classic indicator of granulite facies metabasalts. Orthopyroxene and clinopyroxene, they are stable at high temperatures, while garnet can form under a wide range of pressures and temperatures. Plagioclase and quartz are also common minerals in granulite facies rocks. Next is actinolite, albite, chlorite and epidote. Now this assemblage is more indicative of the grain-chased facies, which occurs at lower temperatures and pressures than the granulite facies. Okay. Next is omphacite, garnet and quartz. Omphacite, garnet and quartz, this assemblage is characteristic of the eclogite facies. Okay, eclogite. And this occurs at even higher pressures than the granulite facies. Okay. Therefore, based on the diagnostic minerals and the pressure temperature conditions of each facies, we can go with option B as our correct answer. That is orthopyroxene plus garnet plus plagioclase plus clinopyroxene and quartz. This is the most fitting mineral assemblage for a granulite facies metabolism. Next question that we have is Glossopteris is found in which of the following formations? Raniganj, Bagra, Lameta or Nimar sandstone? Okay, Raniganj. Raniganj formation is a sedimentary rock formation in India, primarily consisting of coal deposits of the Permian age, and the presence of Glossopteris fossils has been reported in the Raniganj formation, indicating its Permian age and association with the Gondwana flora. Okay, coming to Bagra. Now, Bagra, there is no widely recognized geological formation known as Bagra formation. Therefore, it is unlikely to be associated with the presence of the Glossopteris fossils. Next is Lameta. The Lameta formation is a sedimentary rock formation in India known for its late Cretaceous age dinosaur fossils, and Glossopteris fossils, they are not typically associated with the Lameta formation as they belong to a much earlier geological period. Last one is Nimar sandstone. The Nimar sandstone is a sedimentary rock formation in India, primarily consisting of sandstones of Jurassic age. Glossopteris fossils are not typically found in Jurassic age formations as they belong to a much earlier period. Now, based on the information that we have just discussed, Glossopteris fossils are commonly associated with the Permian age formations, isn't it? So, particularly those within the Gondwana supercontinent. So yeah, among the given options, the formation where Glossopteris is most likely to be found is option A, Raniganj. Okay, go with option A, Raniganj. So yeah, we'll be keeping it till here today in this video. If you want to solve papers like this with me, if you want to prepare for any kind of entrance exams or government job preparation you are doing, then you can join our classes for that. All the details are given in the description box just below this video. You will get it. And if you have any further queries, you can post down your comments below. Thank you for being with me till the end.